Hey guys, in this lesson we're going to take a look at inscribed and circumscribed triangles and quadrilaterals. So to start off with, what does inscribed mean? Well, when you have an inscribed polygon, it's going to be drawn inside a circle so that each vertex or each of those points of the polygon touches the circle. So the way I kind of think of it is inscribed starts with the first two letters is IN, so it's the shape drawn inside a circle. So the polygon is inside the circle. And they can be regular shaped, they can be irregular shaped, just as long as each of those points or each of the vertices of the polygon touches the circle, it's going to be considered inscribed. Well, with the inscribed polygons, there's two special cases that we're going to talk about in this lesson, three actually. And one of them, the first one we're going to work with is an inscribed right triangle diameter theorem. And what that tells us is if you have a triangle, so there's our triangle, and it's inscribed in a circle, we know it's inscribed because each of those 4 points, H, Y, and P, are touching the edge of circle O. And also, one side of the triangle is the diameter of the circle. And that's the part that's important for this. One side of the triangle is the diameter of the circle. So the one side that is the diameter is HP. So if we have HP is a diameter, then we can say we have a right triangle. Specifically, angle Y will equal 90 degrees. So the angle that is opposite your diameter, that's going to be your 90-degree angle. So this angle right here, angle Y, that's going to be your 90-degree angle. And you can also do this the other way as well. They can tell you if you have a right triangle inscribed inside a circle. So with this one, you start with being told that this is 90 degrees. So in this case, angle Y equals 90 degrees. Then you can say that HP is the diameter. So this one starts with the diameter and gives you the 90 degrees. This one gives you the 90 degrees and gives you the diameter. So some examples of problems that use that theorem. With all three of these, you can tell that this line right here is going to be the diameter because it shows you that point right there, and that point is going to be the center of the circle. So that's how you know whether or not one of the sides is going to go through the diameter, is because they give you that point right there. And when they give you that point, that automatically tells you that angle E is going to be 90 degrees because it's opposite of that diameter. Same thing here. Angle P is going to be 90 degrees because it's opposite of that diameter there. And then same thing here for D. Okay. So using that inscribed right triangle theorem and the fact that triangles add up to 180 degrees, that'll help us solve for here. Well, if a triangle adds up to be 180 degrees, and this one's 90, you're going to have 90 degrees left. And it's going to be the same thing for this one and that one. So that means these two angles that are left are going to have to add up to be 180 degrees. Now, if you're more comfortable with doing angle F plus angle G plus angle E equals 180, and then solving from there, feel free to go ahead and do that. But I'm just going to do the two angles that are not the right angle are going to be complementary. So angle F plus angle G is going to be equal to 90 degrees. Because remember, 180 minus that 90 is going to leave us with 90 to work with, which is what those two have to add up with. We know angle F is 33. So 90 degrees. And they're wanting us to solve for the measure of angle G. So subtract 33 from both sides. And angle G is going to be equal to 57. And if you want to double check, you can always do 57 plus 33 plus 90, and that'll give you 180. So looking at the next one, they want us to solve for x. Well, there's x right there. We know all the angles in a triangle add up to be 180. We also know when we have a 90-degree angle, these two are going to add up to be 90. So angle R plus angle Q, the two angles that are not 90 degrees, are going to be equal to 90. So angle R is 2x minus 65 plus x minus 22 is going to be equal to 90 degrees. So 2x plus x is going to give us 3x, and then negative 65 minus 22 more, going to give us negative 87 is equal to 90. Add the 87 to both sides. 3x is going to be equal to 177. Divide both sides by 3. And then x is going to be equal to 59. And if you want to check, we can check. You would do 2 times 59 minus 65. So 2 times 59 gives us 118 minus 65 is going to give us 53. And then to check this one, 59 minus 22. That gives us 73. $37. So then 37 plus 53, there's our 90 degrees. So that's the way you can check and make sure you've got the right angle, answer for x before you put it in for the answer. So these two are what the majority of the problems are going to do. You will get a couple problems that look like this where they only give you one angle. And then you've got to use the rules that we used with triangles where there is a direct relationship between the angles and the sides directly across from them. And if you look, this angle, angle E, is going to be directly related to side DF because it's opposite of it. Well, it says side DF is equal to side DE, and we know because of those tick marks there, or those hash marks. Well, if this side is opposite of an angle that equals x minus 36, this side has to be opposite of an angle that's equal to x minus 36 as well. So basically, if the sides are equal, opposite angles are going to be equal. And what do we know about these two angles? Well, they're in a right triangle, so these two angles are going to add up to be 90 degrees. So x minus 36 plus x minus 36 is going to be equal to 90. So then we're going to have 2x minus negative 36 minus 36 is negative 72 is going to be equal to 90. Add the 72 to both sides. So 2x is going to be equal to 162. Divide both sides by 2. And then x is going to be equal to 81. So there's a couple examples of what it'll look like for them to use the inscribed right triangle diameter theorem. The next theorem that we have is the inscribed quadrilateral opposite angles theorem. So we're still doing inscribed, so that means the shape is going to be inside, or the quadrilateral is going to be inside of the circle with all of the vertices touching the edge of the circle. And what that will do is, if it is inscribed, then the opposite angles are going to be supplementary. Remember, supplementary means two angles that add up to be 180 degrees. And they're talking about opposite. Opposite means directly across from, not touching or adjacent to. So if we look directly opposite, those two angles right there are directly opposite of each other. So angle U plus angle D is going to be equal to 180 degrees. And then if we look here, we've got angle Q and angle A. And they're opposite or directly across from each other. So angle Q plus angle A is going to be equal to 180 degrees. And whenever you take a look at these problems, they can give you all kinds of different stuff. And the big thing is just to remember opposite things are going to be equal. So looking at this one, I know it says S, but we're going to change it to Q. We'll do Q and measure of angle P. It'll be already fixed on yours, but yeah, there you go. So for this one, they want to know the measure of angle Q and the measure of angle P. And this is just testing, do you know the basic inscribed quadrilateral opposite angles theorem? Do you know that angle S and angle Q are going to be supplementary? Do you know angle P and angle R are supplementary, and can you use those to find what the other angle is? So we'll start off with Q and S. There, we know this quadrilateral is inscribed, double checking to make sure that those vertices actually touch the circle, and they all do. So since they all touch the edge of that circle, we know opposite angles are going to be supplementary. So angle Q plus angle S is going to be equal to 180 degrees. So angle Q we don't know, I'm going to leave it angle Q, plus angle S is 117. So instead of writing angle S, I'm going to write 117 is equal to 180 degrees. So now it just becomes an algebra problem solving for angle Q. And if you subtract the 117 from both sides, angle Q is going to be equal to 63 degrees. Not quite done. They still want angle P. Angle P plus angle R is going to be equal to 180 degrees. And again, it's because they're opposite of each other. Angle P is the value we don't know, so I'm going to leave it angle P plus angle R is 74. It's going to be equal to 180 degrees. Subtract the 74 from both sides, and angle P is going to be equal to 106. And if you find the measure of all of the angles added together inside that quadrilateral, you'll find that it's 360. So you can take the whatever angles you find if you were solving for angles and do 63 plus 106 plus 117 plus 74, and that should give you 360 degrees. Okay? Well, in addition to just giving you numbers, they can also start giving you one-term expressions to find values for. And for these, they want us to find the value of x and y. We've got an inscribed quadrilateral, so that means opposite angles are going to be supplementary. So those two right there, and those two right there. Remember, supplementary means two angles that add up to be 180 degrees. So let's solve for x first. So if we do that, we've got 4x plus 5y is going to be equal to 180 degrees. Nope, 4x plus 5x. So 4x plus 5x is going to give us 9x is going to be equal to 180 degrees. So take the 180 divided by 9, and x is going to be equal to 20. Looking at y, we've got 6y plus 96 is going to be equal to 180 degrees. Subtract the 96 from both sides, and then 6y is going to be equal to 84. Divide both sides by 6, and y is going to be equal to 14. And then looking at the last one, it's just another quadrilateral inscribed inside a circle. They just give you a little more to work with. And with these, they want us to solve for the measure of angle T and the measure of angle U. So not only do they want us solving for x like they did here, but you gotta be very careful and watch for them to ask for angles instead of just those variables. And if you put in the x and the y, you're gonna get it wrong. So be very careful with those. Again, we have a quadrilateral that's inscribed inside of a circle, and that is going to make the opposite angles be supplementary. Remember, supplementary means adding up to be 180 degrees? Yeah. So if we solve for this one, we've got x plus 13 plus x minus 25 equals 180. Combine our x's, 2x's, 13 minus 25 is negative 12 is equal to 180. add 12 to both sides, and that gives us 192 is equal to 2x. Divide both sides by 2, and x is going to be equal to 96. Now we're not done yet because it specifically says solve for the measure of angle t. And the measure of angle t is equal to x plus 13. And with these, you've got to be very careful. The opposite angles are not congruent. They could be, but they're not going to be congruent. So you can't just pick whichever one you want to use to substitute x into. You've got to pick whatever angle they're talking about. So the measure of angle t is going to be equal to 96 plus 13. And the measure of angle t is going to be equal to 109 degrees. So there's angle t. Now we need to find the measure of angle u. And before we can figure out what the measure of angle u is, because measure of angle u is equal to 12y plus 56, we have to know what y is. So we've got to solve for y. Well, there's a y in this angle, and there's a y in that angle. And the way those two angles are related is they're opposite of each other. And it's a quadrilateral inscribed inside of a circle. So that means those two have to add up to be 180 degrees. So 12y plus 56 plus y plus 85 is going to be equal to 180 degrees. Combine the like terms. Subtract 141 from both sides. Divide both sides by 13. And y is going to be equal to 3. And we're not done. We need to plug it in. Measure of angle u is going to be equal to 12 times 13 plus 56. So 12 times 13 is 169 plus 56 225. Nope, that's not right. This should be a 3. So I fix that over there. So 12 times 3 plus 56 is going to give us 92. There we go. There's the measure of angle u. So there's just some examples on how they're going to ask you to solve for angles in a quadrilateral given our inscribed quadrilateral opposite angle theorem. And the last thing that we have is a circumscribed polygon, which is basically a polygon that's drawn outside of the circle such that each side of the polygon is tangent to a circle, or tangent to the circle. So there's the tangent right there for BC. There's the tangent right there for DC. There's the point of tangency, I should say. There's the point of tangency for AB, and there's the point of tangency for AD. Now remember our tangent rules. Whenever we're looking at these angles, right here, AD, and then, or A to that point, and then A to this point right here, when we're looking at these tangent lines, remember the length from A to that point and A to that point, they are going to be equal. And then if we look over here and we do the same thing with point B, that point right there is going to be equal or congruent to that, the distance to that point right there. And it doesn't matter how many sides that you're working with or how many points you're working with, those sides are going to be equal. So these sides will be equal there, those sides will be equal there, those sides will be equal there, and they'll be equal there. Now these sides could be equal to each other, but they're probably not going to be. It's going to be based on where those points are. And then the problems that they could have you use for these are problems that look like this, looking at the circumscribed. The majority of the time, from what I've seen, they're just going to have you work with triangles and quadrilaterals. I mean, based on the title of the section is quadrilaterals and triangles. But honestly, they could have you do any type of polygon. So it could be 9-sided, it could be 10-sided. You just got to go with whatever they give you to work with. So one type of problem that they could give you is just to solve for a certain given side. And this, you just got to look at the shape and go, okay, it's circumscribed, which means that's a point of tangency, that's a point of tangency, that's another point of tangency. And given those points of tangency, here's the sides. Those sides right there are going to be congruent. So that means this side's going to be 4. These sides right here are going to be congruent, which tells us that this side right here, so those two, there's one tick mark, that tells us that this side right here is going to be 2, and then looking at the last point, that right there is going to be congruent to that right there, which means this side's going to be 3. And as soon as you get everything labeled like this, it becomes a lot easier to do. So that tells us that this side right here, which is what they want us to find, x, is going to be 2 plus 3. So x is going to be equal to 5. And then in addition to asking you to solve for just one of the sides, they could ask you to solve for the whole perimeter. And again, it's just remembering we've got a circumscribed triangle there, which tells us that this side is going to be equal to that side. And then that side is going to be equal to that side. And if that's true, this side's going to be 12. That side's going to be 7. And then this side right here, looking at that triangle, congruent to that, or sorry, that side congruent to that side, means it's going to be 8. So it's just a matter of adding them all together because that's what perimeter means. So then you're going to do, I'm going to start there, 8 plus 8 plus 7 plus 7 plus 12 plus 12. And you just stick that in your calculator. So the perimeter is going to be 54, and the units we're working with are centimeters. Now, if you notice, we do end up with duplicates of each number, and you should, because each of the sides are going to be congruent for the tangent parts. So if you've got an odd length that is different and there's only one of them from all the rest, you might want to double check the work that you've done and make sure, double check in your sides and see what they are. Alrighty, looking at the last type that we have for solving for perimeter, they could, with these are very nice, neat, simple, easy to do. They give you the exact measurements for each of the little parts of the sides, and all you have to do is put it on the other side and add them together. With these, they could give you entire sides like they did here with the 25 and the 21.8, and then just portions of the tangents there. You're going to want to start with the tangents, fill in the parts that you know right away, and then work from there. So the way that's going to look is, right here I've got a 13, and I know this is a tangent, that is a tangent. So from this point right there to that point right there, they're both going to be equal. So if this one's 13, this one's going to be 13 here. And if this part is 13, and this whole thing is 25, this is where that segment addition property comes back for us. And it's part, so the pink part plus the green part, I'll make it green, is going to give us the whole big part 25. So you just do 25 minus 13, and that's going to give us 12. So that means this green part right here is going to be equal to that green part there, which is also going to be 12. And well, if this part is 12, then that orange part right there is going to be 21.8 minus 12. So this side's going to be 9.8. Well, if these two are tangents to the same circle, this side right here has to be equal to that part of the tangent right there. So that means that part is also 9.8. And then looking at that last little piece that we have to do, this little piece right here is 4.6, which means that little piece right over there has to be 4.6. So you just take all these, put them in a row. I'm going to start with writing it there. So 13 plus 13 plus 20, nope, plus 12 plus 12 plus 9.8 plus 9.8 plus 4.6 plus 4.6. So 13, 13, 12, 12, 9.8, 9.8, and 4.6, 4.6. I guess to be honest, you could just do the 25 there, the 21.8 there, and then add those little bits and pieces in. I like having the duplicates to double check and make sure that I have everything. You can do it whichever way works for you, that's fine. So 13 plus 13 plus 12 plus 12 plus 9.8 plus 9.8 plus 4.6 plus 4.6 is going to give us 78.8, and there's no units on there, so I'm just going to do units. Is the perimeter for that shape right there. Okay, and these three are good examples for the circumscribed polygon, where they could ask you to either solve for just one of the sides or for the whole entire perimeter. And then we also talked about our inscribed quadrilaterals, which tells us if we have a four-sided shape, remember quadrilateral means four-sided shape, inside of a circle with all the vertices touching, opposite vertices are going to be equal to 180 degrees, and we did those examples right there to go along with that. And then the last group of examples that we did were our inscribed right triangle diameter theorem, where if one of the sides of your triangle is the diameter, the opposite angle is going to be 90 degrees, which means the other angles are going to be complementary. Alrighty, if you have any questions, be sure to write them down and ask when you get to class.